Evening class, and welcome to our class today. So today we shall finish up with the financial functions, and specifically today we want us to discuss about the net present value, and we shall discuss about the interest rate of return, So, and from our previous lessons, we did discuss a lot of things about IPV, that is PPMT and such functions. And the application of it, we end up creating a loan amortization chart, which I know most who can do it now. So I know maybe somewhere you have discussed about cash flow, and maybe somewhere you did a number of discussions about cash flow. And today, this is the exact thing that we need to discuss more about the cash flow and how we can apply this one in Excel. So, and the function that we are going to discuss here is one of the functions that we actually use for this. So many of the time is when you are running a business or a business organization, sometimes you'll find people will not actually know the exact cash or the exact cash that is flowing into the business in and out. So sometimes people may overspend. People may spend more money by running a lot of expenses without actually realizing that the cash flow of this business actually is not, that is, the cash flow is not as expected. So when you talk of the net present value, we are actually referring to what? What do we specifically mean by it? That sometimes in a business, the money come in and we have money come out transactions. We have the income versus expenses. That you may see a lot of cash maybe in the cash drawer. Now, just because we have a number of incomes. But at the same time, you must know that there will be time when you will not have any cash in the cash drawer. That means when you talk of the net present value, it is the exact amount of cash or capital that is always in your business, that is flowing the business, that is with considering that there is cash in and cash out. If the net present value, that difference between the present value of future cash inflow and the present value of the cash outflow over a period of time. If the net present value is actually widely used in capital budgeting. So that is, we'll have a topic after this. Once we discuss the net present value and internet rate of return, we will discuss about capital budgeting. And we actually help us to know the profitability of a project. We can actually know the exact profit of the project, that you don't just run the project just because money is coming in and money is going out. You need to actually know the exact amount or the exact profit that this business retains. So if the net present value is positive, then the project should be accepted. So that is, if you calculate and find that the net present value of your project is a positive value, regardless of which value, yes, but it is a positive value, that project is actually doing well. So it indicates that earning from the project is more than amount invested on the project. That is, whatever you are getting from this project is actually more than what you invested. Because you will see here, we have the initial investment, whatever you invested. If you take the cash flow, that is the income, you raise the expenses. Then whatever remains, if you reduce the initial investment, then whatever will remain is what we call the net present value. That is, it indicates that your business or your project is actually doing well because it has exceeded, the cash flow has exceeded the initial investment. So if the net present value is negative, then it indicates that the project in which we invested the money does not provide a positive return. So that project should be rejected. Why? Because whatever we invested in this business is not even gaining anything. So that is the net present value is a negative. So the simple formula of this, we have just said, as we explained the concept, that the net present value here refers to cash flow. The cash flow, that is the cash flow. Cash flow, when we talk of the cash flow, we are simply referring to the cash in and cash out, the inflow and outflow. And when we talk of this, the inflow versus outflow, then we say that the inflow, when you less outflow, then whatever remains, then you less from the initial investment, then you should get the net present value. That is net. You know what the word net means. That the present, we are actually looking for the present value, but not just the value, but the net. That is what you can call yours. So that is I in this formula. I in this formula, that is cash flow divided by 1 minus I. I here stand for the rate of return. That is the discounted rate of return. That is discounted rate. Then the T here represents the time or the number of period the number of period that these investments will actually. So that is what we mean by or how the formula we use to calculate the net present value. So an example of the present value, that is example of the net present value, we can actually experience it in a simple Excel worksheet. And here we are given a company, that is A Limited, wanted to know their net present value of a cash flow if they invest 100,000 today. They invest 100,000 today, and their initial investment in the project is 80,000 for a period of 3 years of time. And they are expecting the rate of return to be 10% yearly. So from these above information, you're supposed to calculate the net present value. So you actually you enter this data very fast. I know you you are there. Just enter that data. Enter that data. Minus, you will not enter the net present value. So that net present value, you don't type the figure, but you just enter the data. And here we are going to use the formula as it is above there. So just 5 minutes. Once you finish, you can say done. If you're finished, you can just say done there, that we can actually have this data. So just type the data. Then once you are through, just type there done, so that you know whether you are finished or not. I believe now you are over by one person done, 2 people. And we get 2 more, then we proceed. Okay, now let's perform that simple computation. I believe you have already mastered that formula. We said the formula for getting the net present value. That is, when you are doing it manually, then you are supposed to take the cash flow. Then we take divide by 1 less the rate of return, then to the power of t, which is the time. And once you do this, then you raise the initial capital. That is the initial investment. So once, the only thing that you need to know here is just master that. You just master that particular, you just master that formula. That is the only thing you need to know. Just master the formula, because we will later use the NPV function in Excel. But even the NPV function in Excel still requires you to have mastered the formula. Why? Because at given time, even with the function, you're still required to add or to minus or to add the initial capital. So let's see how you run this. I want to project this on here. Then we can do it together. So just a minute. So I'll open my Excel worksheet. And this is my simple Excel worksheet. And this was the initial investment. We are given the initial investment here. And the initial investment, according to our question, the initial investment was actually 8,000. That is, this was our argument. This was our argument here that the project, the cash flow was cumulative. That is, this 100,000 was cumulative, meaning that it is a sort of cash flow. When you add the cash flow together, you know, you have some minus and you have some addition. That was resulting to this. It was cumulative. The reason why in this particular exercise we cannot use NPV function, because NPV function will actually requires you to have several values showing the cash flow, the in and out. So that means in this particular exercise, we are going to use the basic formula that we have seen already, applying this formula using the cell reference that you already given. That is, here, we are supposed to pick what? So you start with the equal sign. And just a minute, let me increase the zoom. We'll start with the equal sign. Then you'll take the cash flow, which is this cell here, the cash flow. because we have said that the formula will read cash flow. Then we divide by what? In brackets. Okay, good. I've noted no sound. I think now is okay. So when you get a problem, you can just say immediately, then you can rectify. So we are saying that this company here, we are given the cash flow for 10 years. And we said anywhere you see bracket in Excel, it simply means it is a payment. So these two years here, it means that the cash flow, the cash flow was negative. You see here the 2 years, these are let's can say more of expenses. And all the other years, the cash flow was positive. Now you are supposed to calculate the net present value for this particular company for 10 years. That is, the weighted average cost of capital was given as 15%. If we're considering that, then you see that we consider the weight of equity and the debt also, the cost of equity and the debt. And by having this, the company XYZ Limited, with the following details, wanted to calculate the net present value for 10 years. You can have this data, then we'll insert that function there, and then you see how this function will actually work. So in this case, because you are given you are given the cash flow for several years, then we can use the net present value function. So just have that data very fast, and then we compute that formula. Have that data. that bit. So if you are through, you can say done. Then you proceed. Good. So let's see this function and how it works. Now that you have the data, we will actually have this function. So just a minute, let me open it. So that is our worksheet. And in this worksheet, we are supposed to calculate the net present value for this duration of time. So we are given here the free cash flow for the farm. These are years. And here we have two, which are negative. Then that is the rest are just income. So, and we are supposed to compute this using that function. So let's see how you go about this. So just simple formatting of our work. So the rate here we are given 15%. So you're supposed to insert the function net present value, and you will insert this function from insert function command. That is, you click insert function. Then here you will select the function is net present value. If you don't have it there, you can search NPV. You can search above there. Then click go. The function will actually come down there. And you'll find that this function will return the net present value of an invest based on a discount rate and a series of future payments. A series, if you don't have a series of future payment, then you cannot use this function. You can use the formula direct, use cell addresses, and you compute that the way we did in our first exercise. But when you are given a series of future payments, negative values that shows the payment and positive values that shows the income. As we have seen here, the payment are 2, and all the others, 8 of them are incomes. So then from there, if you ask about the rate, you have to present the rate first. Then under the value 1, we are going to highlight the values. We are going to highlight this cash flow for all those number of years, that is 10 years. And by that, you click OK, and automatically you calculate the net present value for this particular company. So that is how we run this net present value, and that is how you achieve this. I hope that one is very clear. That is net present value. So before we proceed to our next function, there was a question about, there was someone who was asking the question about the lookups, and I said this one is, we'll come to discuss them later. And there's those exercises that I send, maybe I'll forward them again, and you attempt some questions there. So our next discussion, we are going to check on the interest rate of return. That is our next discussion. And first, we are going to check what do you mean by this, the interest rate of return. So in that, you check more on the book. That book I send you there, you'll get the net present value. Maybe before we proceed there, you can attempt that first exercise. That is the net present value. Talked of the formula that we use here. Like in this exercise, we are told that project X requires an initial investment of $100 and is already recorded here in cell B5. Then we expect a profit of 0 at the end of the first period and a profit of 50 at the end of the second period, and another profit of 150 at the third period. So that means if we are to use these profits that we are expecting, that is 0, 50, we actually get 200. That is if you are to calculate this. But you see, the initial payment was $100. That is what was invested. So maybe you can see the discounted rate is 15%, as we have seen here. The explanation that this rate of return is best alternative of investment. That is, for example, you could also put your money on a high yield saving account at the interest rate of 15%. That is, that 15% was actually the interest rate. So the net present value formula to calculate the net present value of the project is supposed to be run here. But now here you'll notice something different a little bit, that if the cash flow, the initial capital is negative, then our formula, we will not deduct the initial investment. Actually, we will add, because it's minus, which will give us plus. So I want us to run this and see how it works. And we'll actually get this, that this, where is that exercise? Just a minute. I want to open that exercise. Then we can discuss together. We close this one first. So you can feed that data. Let me project it. You have told project X. You have project X. And that project X have that data. Project X. So we can even have it here. Let's type it direct here. Just a minute. Maybe. So we are given their project, and we are told that this project the discounted rate is 15%. The periods, we start with the first period, that is 0 period. That means it is actually 0 period. It means this was the initial investment. But notice that here it is indicated minus, meaning that it was actually a payment. It was actually a payment. Then the first period, the company expected 0 profit. The second period, it expected an inflow of $50. And the third period, it expected an inflow of $150. So now with this, we are supposed to get the net present value of this amount. So notice that our series of payment are this. These are our series of payments. That is from this cell to this cell. That is our series of cash flow. That way we will use this function because we are actually given that series, unlike other function where we are not given this series. Then our net present value will have it here, NPV, and we will insert this function. Remember that our formula, if you remember very well, our formula of calculating the net present value, from above there, we said that even from here, we are told that the NPV, you calculate the present value of a series of cash flow, subtract the initial investment, subtract the initial investment. But we do this if the initial investment was positive. We only do that if the initial investment was positive. Like in this case, our initial investment was positive. It was positive, that is 80,000. But in this exercise, our initial investment is not positive. We are given actually a negative value. So that means when you insert this function, you actually insert the function, the rate you are given here, and this is our cash flow from 1 to 3. But now, once you finish this, we will have to add the initial investment. So, and when you add, we get the net present value. Notice that if this was positive, then we have to do the other side. We have to minus the initial investment. So to follow the formula, and by doing that, then you'll find the formula will still bring the same value. The formula will still bring the same value. So I repeat that we are actually inserting the function NPV, and we'll select NPV. We insert NPV in our function. Then the rate is given, the discounted rate is given here, and the values of these are the cash flow from here. You have the cash flow from here. So that is what we expect. But our installment, that is, this was installment. That is what was invested. We are supposed to minus after the function, because when you set the function, you have to deduct from the formula. You can see the formula above here on the formula bar. We are supposed to deduct the initial investment to get the net present value. But if this was actually indicated in Excel as minus, because sometimes Excel will indicate this one as minus, indicating that it was a payment, kind of, then our formula will have to change so that it will not show us actually something wrong, because here it will show something wrong. It is actually showing 200 plus 36, which is very wrong. You're supposed to put a plus sign so that we still get the same value of net present value. So that is how you run that net present value in that particular function. So I think that one is clear, and I have just gone through what is in that book. So as you go through now, you understand why it was plus. Yeah, the reason why it was plus because the initial investment was given as a negative one. So you'll go and get more information on the second exercise, that is project Y, and try to run that one too at your free time. So our understanding of the net present value function, that is the net present value function simply calculate the present value of a series of future cash flow. This is not rocket science actually, because it's something that we did even using a formula. So in the two projects, we have seen that. And we have actually got the two values. We are able to compute and get the net present value for those two projects. So our next discussion, we'll actually check on the internal rate of return. And just before then, yeah, so at your free time, you'll go and check more information I've given there about project A and project B. There was something we are actually to compare between these two projects, because we want to actually compare about this net present value, that for the project Y, which now this rate of return change. That is, if you check the project Y, and from our previous exercise, we have seen in the previous project X that we were able to find the net present value of $36. But if you are to interchange these values, you find something different. And that is what we actually see here, that the rate of return of the best alternative investment, for example, you could also put your money on the high yield savings of 15%. We have already seen that. But on the other end, that is project Y, you'll find that the period here changed. The initial investment still remain negative, but the first period was 150. The second period was 50, and the third period was 0. That is, the explanation of this is that the net present value of project Y is higher than the net present value of project XX. Therefore, project Y is better to invest. So let's see whether this one will actually behave that if you change those values in our project. This was project X. You want to copy this, you can even try that. You copy this data, jump one cell, and paste there. Then you can name this project as project Y. The rate of return still remain the same. The cash invested here, the cash flow, still remain the same. That is cash flow. And this was, we can actually name this one, it was initial investment. Initial investment. Initial investment. Yes, so this was initial investment. Let's format this data properly. Just a minute. I believe now that people are conversant with formatting the data, because sometimes if you format data wrongly, then it might end up giving challenges in inserting function. That data is supposed to look like that. Now it makes more sense when it looks like this. We can replace now here. So I've just copied this data, but rename this project as project Y. In project why we actually invested the same cash. But the cash flow was different. We started with 150. We are not changing the formula. It remains 0. We just change the formula. We just change the values. Notice kind of magic. You can notice that. Who can explain this? Who can really explain this? Why is project Y actually better than project X? Why is project Y better than project X? The two projects, we invested the same amount. We have 3 periods. Only that here, the period, the first time we expected 0. The second one, we expected 50. And the third one, we expected 150. So someone says that time value of money, that is exactly what we are looking for. The time value of money matters a lot. So that way, the two projects, it was better to invest in project Y than to invest in project X. So if you check, the net present value of 2 are different. So, and that's the reason why these two projects are actually, so that means when you get this cash in faster, it is better than maybe you delay that time of delaying, that money takes time to delay. Maybe it will come to those end years, those end years that the project you run, but you are expecting this money at the end of your investment period of time, then that is not better than the one that is giving that investment at the beginning of time. So that is the difference between the two. I hope that one is very, very clear. So, and that's what we mean by net present value. And you have seen that clearly, that it is better, it was therefore better to invest in project Y. So understanding this NPV function, then simply, NPV function simply will do that calculation on that. So, if you check another case here, there was another case scenario whereby we had project A and project B. The two projects again had the same invested amount, but the time in the cash flow was different and both giving different values. And let's see something again different. We can use the same data to compute this. We have projects. I will just copy this data to the next worksheet. Just copy this data and move it to sheet 3 and paste there. So then we change the project. This one, instead of project X, we can call it project A. And this one, you can call it project B. So this is project B. The rate will remain the same. We are not touching the rate, and we are not touching the initial investment. The only thing we are touching, the formula still remains the same. That is net present value. You know, the net present value, we say the cash flow minus the initial. So the cash flow, the initial investment here was minus. We want to change this. Let's change this one now to positive. Excel will actually take it as reduction. If our formula will automatically change, and we will put here minus. So change to the two projects. Let's put our initial investment as, this is in form of dollars, $100. So, and change the formula, because the formula is supposed to be the cash flow minus the initial investment. Now, in the first project, if you check here, project A, The first period they expected 0 profit. The second year they expected 0 profit. The third year they expected 152.9. So let's put that. So here we put 0, 0 again, and here we put 152.09, 152.09. Notice that the net present value is 0. The net present value is 0. So here we will do the opposite. That is, we'll type 152.09 here, and the others will remain 0. Now look, the difference between the two projects. That the cash flow here, the first time they expected this amount. Then the two subsequent years, they actually expected 0. But they get a higher net present value than this project A. Again, we said, explain this reason. The reason is simply that time value of money actually matters a lot. So it was even better to invest in this project than to invest in the other project. That is what that net present value, if you understand it now in a more deeper way, then you can explain why it was better to invest in that project. I think that one is okay. Now we can proceed to our next discussion. So our next discussion about the interest rate of return, So I've not started yet. I was just taking something. So now we are about to proceed. So just a minute. Please. I want to compute some data that you are going to use for IRR. Then we can use it there to perform those computation. So just a minute. So then we're back. So IRR, we said it means the internal rate of return. And again, we are going to check how this function actually help us and how you can use it in Excel. So, and first, we need to understand it better. First, you understand what it means before we start doing the practical examples. Remember that the book I send you is just a summary of these functions, because you cannot actually, if you compile everything in the book, you'll be so big. So that's why I decided I just give some simple functions and simple examples so that you'll be able to master each one of them, and you can use even to compute more other functions, more function. Remember that the complexity of data will not change. The complexity of data will not change the function, it will still remain the same. So first, we need to check this function and first understand what this function is all about. And here, I have a simple insight of this function, the internal rate of return, calculation in Excel. And we say that the internal rate of return is used to calculate the internal profit for some investment in financials. The internal rate of return actually itself is an inbuilt Excel function which you can insert in Excel. That is, when you are working in an Excel worksheet, this is a function that you can actually insert. That is, if I'm just using a blank worksheet here, and you click insert function, then you search IRR, then you go, it will actually give you that function. That is the return internal rate of return for a series of cash flow. That is a function that you can actually insert from Excel. So that means is an inbuilt Excel function that you can actually work with. So, and being an Excel function, it means then somewhere we are going to insert it to compute our to get our values. So it can also be a financial formula. This function takes a range of values as an input for which we need to calculate the internal rate of return, and a guessed value as the second input. As you have seen there, that the minute you insert that function, its function argument gives you two values. One, the value, then there's something here. The value is an array of a reference or a reference of cells that contain a number for which you want to calculate the internal rate of return. That is that series of numbers. Where the guessed value is a number that you guess is close to result of IRR. 0.1 or 10% if is omitted. That is, if it is omitted, it's usually 10%. So that is what we mean by this. So, for example, suppose your company made an initial investment of 50,000 and unexpected and expect to generate that is $10,000 every year for a second, that is every year for the next 10 years. For the next 10 years, we can use this data to compute, to calculate the internal rate of return of this investment, which is the rate of return you may get in your investment of $100 as a result. So the internal rate of return comes out to be 5%. It is equivalent to the money invested at 15% for 10 years. So I hope you actually got that. That internal rate of return Excel stand for it stands for this. It is an inbuilt function we have seen available in Excel, and in addition, it falls under the category of financial functions. The internal rate of return is the interest rate, is the rate of interest received for an investment. The rate of interest received from an investment made. The rate of investment received from an investment made. That is one thing you need to understand. It consists of the payments made represented by the negative value and the income generated donated by the positive value that occurs regularly. So we have already seen that the negative values always represent the payments and the positive values represent the incomes. So, and the internal rate of return function in Excel returns the internal rate of return for a series of cash flow represented by positive and negative numbers. This cash flow do not have to be consistent as they would be for annuity, that is yearly. However, the cash flow must occur at regular intervals, such as monthly, quarterly, or annual. So the cash amount can vary for each interval, Now here we are going to use a simple formula, and we are going to actually have this data. We'll actually have this data. And just a minute, to rectify something. So just a minute. Oh, you type the data. No sound again. Just a minute. So just a minute, I want to rectify something. There's a value we need to change here. Okay. The value we need to change so that now we can have the data, we can enter in the data and we compute the function. Okay, so it's done. Vision. You are through. Okay. So these are our data. So just have this data and type the data in your Excel worksheet. You can open a new worksheet and enter in the data. That is, don't use the previous worksheet that you used there before. Just have a new worksheet. So the worksheet is given here. You are given the input data. Here we are given years, the description. Given the description. Then here we are given the internal rate of return function that we are going to insert in our Excel worksheet so as to compute the function. So year one, we are given this, that is, as it was 10,000, the year two, year three. This is amount invested. This is the amount income generated for the second year, income generated for this year. So the internal rate of return after the third year will be this. Internal rate of return after the fifth year will be this. So if you just have that, then you insert our functions there. So I hope you already have this. Enter that data. Then once you are through, and just say done. Then you can have this function we started together. So amount, so you have this. Once you are through, you just say done. Then you can finish up. We can enter that formula together. You will use amount in dollars. Then we have description. Description. Have year one. Year two. Year three, year four. amount invested. So if you compare this with our previous example, then you realize that there is something lacking here. And what is lacking is what we are referring as discounted rate. Everything else is available apart from the discounted rate. Now, I think from here now you get why we are calculating that. We are actually calculating the rate. So I hope now you have completed typing the data. So let's have it in our worksheet. So I open it in Excel and that was our worksheet. Can align our figures properly. So, and here you are supposed to generate some info, that is the rate. So we can now use this function for IRR, that is internal rate of return. And according to our computation, that is this exercise, if you are told to generate or to calculate the IRR after 3 years, then our function somewhere here, that is IRR after 3 years. Then how do we get this function? We insert the function, just like we have done in other formulas. And when inserting this function, there's something that you'll notice, that the formula used to calculate this has the following, that once you insert, it will ask you about the range. And the range this requires is a required parameter. A range of cells denoted or denotes a series of cash flow for which we would calculate the internal rate of return. We talk of the guess. This is the option parameter. It denotes the number that you guess is close to the result of the internal rate of return. If no value is mentioned here, then it takes the default value of 10%, that is 0.1. Then this bracket denotes the optional parameters, which probably are not given. If the function returns the numeric value, that could either be positive or negative. When you insert these, then our function will be like this. So we start with this one here, and we insert the function IRR. Then you see, then you select the function, click OK. It will ask you for the value. The amount invested is this amount here. And the guess number, like if you are looking for this year, that is year 2, then you can take year 2. You can take year 2. Then you want to see the reaction of this formula and what you're going to get. The value, just a minute. Okay, it might give us now. Just a minute. Let's see. So there is somewhere there was that explanation of why sometimes when you insert the value, it will give you a num value. So, and we actually to set up the value, the value that is actually highly required is the first value. That is the invested amount. So probably the guess value we can assume it is 0. So again, just a minute. I think there is a problem. Let me check. A minute, please. So IRR. Yeah, so we should put a range of cells, not we're supposed to choose a range of cells, not a specific value. We're supposed to choose a range of cells. If it is from a specific value, like in this case, from this value, then up to, say, like up to here. Okay, just a minute, let's see. It will give us 80%. 80%. Okay, we're supposed to reach which? Let's insert it again. Supposed to move up to the third. Yes, supposed to move up to the third. That is of the third year. The income generated IRR for the third year supposed to be 19%. 19. So that is you move up to the third year to get these amounts. So you've seen what we have done. So you can repeat that formula again. That you want to insert that function, IRR. Then we will combine together with this, which we say that is the amount invested. We will insert the function IRR. Then we highlight the cells from this, that is the first year, and you want up to the third year, IRR up to the third year. And once you do this, it will give us a value that is 0.0185, which will be rounded off to the nearest, that is percent, and it will give us that amount. That is 19%. So if you are to get up to the 5th year, that is the IRR after the 5th year, we can have it somewhere here. And we want to check for 5 years. Then how will be our function and what will be the value? This is yes. We will insert the same function again. So we just insert function IRR, then okay. Then we will select the range from this first year up to the 5th year. And when you do this, it will give us that rate. Notice that now it gives us a positive value because we have said that it can give a negative value or a positive value. So let's go back here that we say this function may return a numeric, always return a numeric value. It could be positive or negative. Now that is depending on the cash flow, that is the series of numbers that you have. It may return a positive value or a negative value as we have seen in our formula. So that is one way of inserting that function. That is the the internal rate of return. So I think that function is clear. So you select a series of values up to the value that you want. If you want the third value, you have to select up to the third value, and you get that amount. If you are to run this example here, then you say that the internal rate of return example calculates minus 3,000 denotes the capital amount invested. The following numbers, that is the 2,000 and the 5,000, indicate the income that has been generated in the subsequent years. The internal rate of return function Excel calculates these values, and the result of this is 67%. That is when you run that function. Maybe in case you get this, what does it mean? That if you don't have a negative value, sometimes it may end up giving a num value here. When you get this, you're supposed to know how to convert this one to a number. In this case, you're given this case, whereby, let me use this simple function here. I'm going to type those values in a new worksheet and see what will happen in case you put that amount and it gives you, or you don't have a negative value. Like here, I want to use another example. We are given the amount, the initial amount is 3,000. where you put the amount invested there as negative. And when you do that, it will automatically give you the internal rate of return as this percent. This guy is saying they are not hearing anything. Okay. So I will repeat that when you say, or we talk of internal rate of return, we have already computed this. The amount invested was 3,000. And this indicates the incomes. This is the income, and this is another income. We have two incomes. So, and to insert the function, we said we insert the function IRR. So we click on the function here, we select insert function, then it selects internal rate of return. Then the values, we have here these values. We said the guess, we don't have any guess for now. That is, we said this guess indicates the value that you guess to be close to the internal rate of return. If you don't have that guess, you can leave it or you can omit that. But computer will automatically give 10% of that. So automatically it gives us this. But if the internal rate of return was positive, then the formula gives us this value, showing that it simply indicates, we have already indicated that it indicates that no single negative payment was found. That is, there was no any kind of payment that was there that was done in this scenario. So that way it returned this error, and that error will remain there unless you use a function to remove it. You cannot rectify that error. It will just remain that value there. So whenever you see that value, automatically you know that there was something omitted in our data. A negative value need to be there. That was example one. I think that was very, very clear. So the next example, maybe as we wind up, we're still going to check another example here. Now that we get this error. Now there is a sign that appears just close to the error. Let me just click undo and repeat this again with a positive value here. And I insert the function IRR, the values here, then okay. Always you'll find this, there is this icon that appears here. This is a problem with the number used in the formula. The problem with the number used in the formula. In errors, we found errors in Excel that to rectify, when you click this, we have a number of ways of checking this. Checking options, editing the formula bar. You can edit that formula in the formula bar. It takes you to the formula bar where you go back and edit the formula. So what are you supposed to do here? Then we are going to see that in case you get this, then you can choose the first option. You can choose the first option. That is, you can select number error, but really is a number error. You can show the steps of running this. It will actually show you this. Then from there, you can evaluate. It gives you the same error. So that means this error will have to go back to your data. That is the only way to solve the error. You go back to the data and you need the amount invested. Any payment have to be put in a negative sign. So that is how you rectify that error. You can rectify error in so many ways. If all the values were negative, then what do we get? If all these values were negative, then let's see what you get. That is, we don't have any income. Here in our data, we have all negatives. Let's see what will happen. It will give us the same error. So that means the cash flow, that shows that in this, you cannot calculate the rate of the internal rate of return, whereby we have all negative values. At least there have to be some positive values showing income and some negative values showing, like in that case, the internal rate of return is 0. We had this amount invested, we had this, which was it was actually a payment, and this was an income. If we add more income here, maybe you have another income of 4,000 in the next subsequent year, and we extend our formula. That means we extend the formula up to A9. Then you'll notice that the internal rate of return will automatically change to 33%. So maybe in this case, let's go back to our argument. In this IRR example calculation, all values being negative, therefore it indicates it generates no income, and it result to that error. Example 4, we already did this there previously, and actually we were able to calculate the internal rate of return for the third year and internal rate of return for the 5th year. So just to repeat this, we said to get this, just insert the function, internal rate of return, then you select the range of values, you move up to the 3rd year. And this one will give you the internal rate of return of the 3rd year. So I think that one is clear. So that is how you run the internal rate of return function. I think I will send the exercises there in WhatsApp group. Then you can attempt, and once you finish, you send your results. You send your results in the same WhatsApp group. So today, that will mark the end of our lesson. So our next lesson, now we have done most of these financial functions. I think now you'll see from that booklet, actually that was almost the last part of that of financial functions. So meaning that in our next lesson, we are going to discuss we are going to check about something we call scenario analysis. If you check from our course outline, you'll see something like that. That is scenario analysis, and scenario manager, data, tables, and there's something we call the goal seek. So I'll prepare some notes for this. Then once we finish, again we will send them to that WhatsApp group. So that one will be on Saturday. That we will have our next class on Saturday evening. So where we will discuss that. So before Saturday, then I'll have sent several exercises that you can attempt that covers whatever we have already gone through, and it will help you to understand that concept better. Now, to the book that I send you, now under the internal rate of return, you go and check, then you compare, as we did in net present value. What is the effect of this when it comes to our projects? You can go and test that. That is, in the previous project we had, let's maybe check a little bit so that you can go and now check on your own. We had these projects. We had project X, we had project A and project B. There is something that we saw that is what we are referring to then we are referring to the time value of money. That if you invest the same amount and the cash flow is different, then the project is giving us net present value that is different. Suppose we are to do the same with the internal rate of return. We want to do the same thing. We want to see whether the internal rate of return will be the same. Here, we are ignoring the rate because we assume the rate was not given. And we want to see this effect, how it will affect our value. So, just a minute. So if we insert this function, the amount invested still remains the same. But now, here it means you have to change our data a little bit. We cannot use this data as it is here because we actually need to highlight the range of cells. So maybe we'll just do a simple analysis, just copy this data to the next worksheet. Then you will change this. To edit this. You can cut, paste somewhere. Cut this one, paste here. Then you can cut this one and return it back here. So you should format your data in that manner. Now let's remove this. Oh, we don't have to remove that because we had a previous calculation. So format that data, format it that way. Then we'll call this one project M. And you copy this one here. You have another project N. Yes. Huh? Wait. So you format your data that way. That one you do it very fast because I want to wind up. You just format your data that way. Then you insert the internal rate of return. With this data, we are going to interchange the values. Here we will start with $150. Sorry, $150. Here we have 0, and here we have 0. So then this one will be like this. So the amount invested will still remain the same. Then insert the function IRR for the values up to here. Don't include the net present value. Then again insert IRR for the next project. That is from here to here. Then notice the difference between the internal rate of return. Now, I need an explanation for that. You can send that one in the group. Why do we have different rates, yet we have the same values, only that the period is varying. Period is varying, so this set is as 0. So 150, 0, 0. So this is supposed to be, so set here 50 and here 50. So we get here the internal rate of return in project M is lower than internal rate of return of project N. So then there you can give an explanation of why that is so. So we are going to wind up our class there today, and we'll proceed on Saturday.